Hello students, let us go through one more sum based on graphical method. The sum is solve the following simultaneous equations graphically, and the first equation given is 3x minus 4y is equal to minus 7, and the second equation given is 5x minus 2y is equal to 0. Let us start with the first equation, that is 3x minus 4y is equal to minus 7. Now the first thing is write it in the form of either x is equal to something or y is equal to something. For that we need to shift the variable with the bigger coefficient to the other side. So let's do that first. So what we get is 3x is equal to minus 7 plus 4y. But here what we get is 3x. What we want is x. So we need to take this 3 to the other side now. So ultimately x is equal to minus 7 plus 4y is equal to upon 3. So this is the first time we will actually be dealing with a denominator. Now how do we do it? What changes as far as the assumption is concerned? Let's see. So we get x is equal to minus 7 plus 4y upon 3. Draw the table x, y, x comma y. Now because y is in the right hand side, we need to assume any 4 values of y. But here be careful, you cannot blindly take 0, 1, 2, 3. You cannot, because there is a denominator, and if this denominator was 2, not a problem, but the denominator is 3. So all the numbers are not divisible by 3, right? So you can get a non-terminating fraction also, which you cannot plot on the graph paper. So we need to take care of these things as far as a fraction is concerned. So you can't just take 0, 1, 2, 3. So what do we do? How do we assume? Let's try and understand that now. Let us start with 0. What happens when y is equal to 0? Let us take y is equal to 0 and see the calculations what happen. Now when y is equal to 0, x is equal to minus 7 plus 4 into 0 upon 3, right? So it is equal to minus 7 plus 0, 4 zeros are 0, upon 3, that is minus 7 upon 3. Now minus 7 upon 3 you cannot plot on the graph paper, right, because minus 7 upon 3 is 2.333333. It cannot be plotted on the graph paper. So we cannot assume y as 0, because it cannot be plotted. X is equal to 7 upon 3 cannot be plotted on the graph paper. So now because 0 is not a valid assumption, let us take y as 1 and check the calculations. Now what happens? Let's see. When y is equal to 1, it is x is equal to minus 7 plus 4 into 1 upon 3. That's minus 7 plus 4 upon 3. That's minus 7 plus 4 is minus 3 upon 3. Minus 3 upon 3 is minus 1. So when y is equal to 1, x is equal to minus 1, we are getting an absolutely point to be plotted on the graph paper, right? So in other words, y is equal to 1 is a valid assumption, right? So we tried with y is equal to 0, we didn't get, right? We got x is equal to 7 upon 3, which we cannot plot on the graph paper. Then we took y is equal to 1, we got x is equal to minus 1. Now you check with 2, it won't be a valid assumption. 3 won't be a valid assumption, but 4 will be a valid assumption. Now the question is, how do we quickly know that 4 would be the next valid assumption, right? It's easy. Understand this trick. 1 is a valid assumption of y. Now for next, because the denominator is 3, it will be in a gap of 3. 1, 4, 7, 10. Remember this. So when if the denominator would have been 4, then it would have been 1, 5, 9, 13 in a gap of 4, either in the positive side or in the negative side. Anything is valid. But the gap should be equal to the denominator. So here it is 1. Then next is say 1 plus 3, which is 4. 4 plus 3, right, which is 7, and 7 plus 3, which is 10. Now see what happens. When y is equal to 4, x is equal to minus 7 plus 4 into 4, which is minus 7 plus 16 upon 3. which is equal to 9 upon 3, which is equal to 3, which is a valid value. You are bound to get a valid value because now we are going as per the denominator. First was 1, then 4. Now assume y as 4 plus 3, which is equal to 7. Got this? So this is a technique where you can actually find the next assumption very quickly. Go on increasing as per the denominator. Here the denominator is 3, so we are increasing by 3, the assumption, right? Now what happens when y is equal to 7? Just check the calculations. You get x is equal to minus 7 plus 4 into 7 upon 3. That's minus 7 plus 28 upon 3. 28 minus 7 is 21 upon 3, so which is equal to 7. So when y is 7, x is 7, point is 7 comma 7. Easy. Now next valid assumption has to be 10, but if you remember, I told you y is equal to 10 would be the topmost point. So 10 it is better not to assume. Then what you can do is you can go towards the negative side. We were like adding 3, we were adding the denominator. For the last value, just subtract the denominator, that is 1 minus 3, right? And you get it as minus 2. So let the last assumption be on the negative side, that's minus 2, right? So when y is equal to minus 2, you get x is equal to minus 7 plus 4 into minus 2 upon 3. That's equal to minus 7 minus 8. 4 into minus 2 is minus 8 upon 3. That's minus 15 upon 3, that is equal to minus 5, an absolutely valid assumption, and you get minus 5 comma minus 2, right. So this is the first time we dealt with the denominator, and what did we learn? We can't just blindly assume 0, 1, 2, 3. Start with 0, if it is valid, good. If no, then check for 1. 1 turned out to be valid. Then once you get the first valid assumption, then go on increasing or decreasing by the denominator. 1, then because the denominator is 3, next has to be 4, 7, 10 or 1, 4, 7 minus 2 as per your comfort, but 10 generally, because as I said, it is the topmost point on the y-axis, better avoid, right. Let's move on to the second one. 5x minus 2y is equal to 0. Shift minus 2y to the other side, you get 5x is equal to 2y, right. So you get x is equal to or rather y is equal to 5x upon 2. Now here the problem is not there because denominator is 2. So when the denominator is 2, either it will be an integer when you divide, or it will be something 0.5, which can be easily plotted on the graph paper. So here the assumptions will not be a problem. We get y is equal to 5x upon 2. Draw the table x, y, x comma y. Right hand side is x, so you can assume the multiples of 2, the tables of 2, 0, 2, 4, minus 2, absolutely perfect, right. So whenever the denominator is 2, these are the values you can assume, 0, 2, 4, minus 2 or 0, 2, 4, 6, right. Now let's take x is 0, 2, 4, minus 2. Now substitute the values of x and get the corresponding values of y. When x is equal to 0, y is equal to 5 into 0 upon 2. So y is also equal to 0 and you get the point as the origin, that is 0 comma 0. When x is equal to 2, y is equal to 5 into 2 upon 2, that's 5. So that's 2 comma 5. When x is 4, y is equal to 5 into 4 upon 2, that's 10, right. 10 you can always avoid by not taking it as 4, right, because as I said, it's a topmost point, nothing else. And x is equal to minus 2, you get y is equal to minus 5. So you get minus 2 comma minus 5. Now you plot it on the graph paper. 10 comes on the graph paper, but if at all you are not comfortable with 10, you can you can assume x as minus 1 also. Minus 1 or minus 1 also is fine, because when you assume x as minus 1, you will get minus 2.5, which is plottable on the graph paper again, right. Now let's plot the points from the first table. The first point is minus 1 comma 1. Minus 1 comma 1 is in the second quadrant. 3 comma 4 is in the first quadrant. 7 comma 7 is in the first quadrant. Minus 5 comma minus 2 is in the third quadrant. All the 4 points are collinear. Join them. Don't forget to write the equation on it. 0 comma 0, 2 comma 5, 4 comma 10 and minus 2 comma minus 5. Join them. Don't forget to write the equation on it. Look at the point of intersection. The point of intersection is very clearly 1 comma 2.5. So 2.5 is not a problem at all. Write the final answer. The solution is x comma y, which is 1 comma 2.5. The final answer should be below the two tables on the main answer sheet. Always remember that. As simple as that.